In this question, I want to explain how the genes are originally linked in the 300 parents. I go step by step based on the data provided. Part 1. Data and observation. We have the progeny count 1761 for the TCD combination, 1773 for TE, and smaller number for double crossover like 6 and 8. From this, we can see that most progeny follow a certain arrangement, which is show that these genes are indeed linked. Part 2. Gene arrangement. If we look closely, the gene K and CD are located on the same chromosome, while E sit on the homologous chromosome. So when we perform a test cross with the 3 hybrid female, the recombination pattern review this arrangement. Part 3. Double crossover, DCO. In the DCO calculation, we get very small value. For example, 6 for KCD and 8 for W. This tells us that crossover events are rare, but they are enough to prove that these genes are positioned close together.
B. Next, we need to estimate the distance between the genes. First, determine the gene order by examining the double crossover classes which have the lowest frequencies. These classes are kidney eboni, cardinal with 6 progeny, and wild type with 8 progeny. By comparing the parental classes with the double crossover classes, we can identify that the gene E is located in the middle. Therefore, the gene order is K, E, and CD. And next, we calculate the distance between K and E. The recombinant classes for this interval are kidney with 97 progeny, eboni cardinal with 89 progeny, and the 2 double crossover classes with 6 and 8 progeny. The total recombinant for progeny is 200. Using the calculation frequency formula, which is recombinant progeny divided by total progeny multiplied by 100, we obtain 5%. So the distance between K and E is 5 centimorgan. Okay. For interval between E and CD, the recombinant classes are kidney eboni with 128 progeny, cardinal with 139 progeny, and the two double crossover classes with 6 and 8 progeny. The total recombinant progeny is 218. After calculation, the recombinant frequency is 7 centimorgan.
Now, I continue with question C. Question C asks us to calculate the interference value. First, I state the formulas. Consequence of coincidence equal observed double crossover divide by expect double crossover. Interference equal 1 minus coefficient of coincidence. For step 1, we have to find observed double crossover. The least frequency of spring are the double crossover types. From the data, we have 8 plus 6 equal 40 individually. So the observed DCO we get is 40. For step 2, we have to calculate expect double crossover. Distance between gene K and CD is 0.05. Distance between gene CD and E is 0.07. Total progeny equal 4,000. For expect number equal 0.05 multiple by 0.07 multiple by 4,000. That gives us 14 individually. So expect DCO we get is 14. For step 3, we have to calculate coefficient of coincidence. Coefficient of coincidence equals 40 divided by 40, and the result equals 1. Step 4, calculate interference. We have to calculate the interference. Interference equals 1 minus 1. The final value is equals 0. This is meaning when the interference is 0, there is no interference at all. This means one crossover do not reduce or block another crossover.
Next, we calculate the expected number of a double crossing over. We multiply the recombination frequency between the two gene interval 0.07 and 0.05, and then multiply by the total number of offspring, which is 4,000. This means we expect 40 double crossing over offspring. The expected frequency is 0.35%. Since there are 2 double crossing over classes, we divide by 2, giving 7 offspring each class. Therefore, we expect 7 kidney eboni cardinal offspring and 7 wild type offspring.